What if a planet could freeze its own sky and drop it onto the ground as snow? Not metaphorically, literally. Gas turning solid, an atmosphere collapsing onto ice, world at the edge of the solar system actively throwing heat into space, while the surface below stays comparatively warmer. James Webb pointed its instruments at Pluto and confirmed something that should not fit our usual picture of planetary weather. Pluto appears to be cooling its own atmosphere in an extreme way. No other known world in the solar system does refrigeration like this. The readings were so strange that climate models built for decades had to stop and restart. The air far out there was colder than accepted physics expected for that tiny, isolated body. So the question becomes unavoidable. How does such a small, distant world pull that off? For a long time, science treated Pluto as a dead rock at the end of the neighborhood, leftover. Punchline after the demotion. Webb's data forced a rewrite with no realistic chance of sending a new spacecraft to that frontier for decades. The only option was to watch from here carefully through instruments that can separate light that used to blur into one glowing smear. That smear always had a name: Charon. Charon is enormous compared with Pluto and orbits extremely close. For older telescopes, the light of the two bodies melted together. You could not cleanly read Pluto's air without Charon's contamination. Webb changed the game. Gold-coated mirrors, infrared vision, spectrometers precise enough to peel Pluto's chemical signature away from Charon's temperature, gases, behavior, without needing another flyby camera pressed against the ice. What those spectra revealed is the opposite of a greenhouse. On Earth and on Venus, an atmosphere tends to trap heat. It holds solar energy and keeps the world warmer than naked vacuum would allow. Pluto's haze does the reverse. Fine chemical particles absorb the scarce sunlight that reaches that far, then dump that energy straight back into space as infrared. The atmosphere acts like a radiator. It throws away the little heat the planet received. The air becomes significantly colder than the frozen ground beneath it. Picture a hot pan in a sink. It cools by releasing heat into the room. Pluto does something related, except the room is empty space, and the radiator is the atmosphere itself. DC atmospheres are not simple blankets. They can be engines of loss, and that loss points at a future. Pluto's orbit is stretched. As it drifts farther from the sun, it receives even less light. The cooling accelerates. Nitrogen, the main ingredient of that thin air, can fall below the threshold where it stays gassed. Then the sky begins to fail. Nitrogen snows out. Pressure drops year by year. Within a few decades, models say the atmosphere can vanish into a solid crust on the ground until the long orbit brings Pluto closer to the sun again more than a century later, and part of that sky may rise once more. World that exhales its atmosphere into frost, then waits for sunlight to breathe again. Webb's recent confirmation does not stand alone. It locks into mysteries that exploded into view in July of 2015, when New Horizons raced past Pluto and shattered the dead rock story. Instead of an ancient cratered corpse, the spacecraft returned a bright heart-shaped plane, moved forward and renewing itself. Beside that frozen heart rose mountain chains kilometers high, not of ordinary rock, but of water ice so cold it behaves like granite. Imagine icebergs hard enough to hold as mountains, carried slowly on a bed of frozen nitrogen, sliding almost without notice across a landscape that looks borrowed from another solar system. Then came cryovolcanoes, peak craters, not fire and molten rock, paste of water, ammonia, and frozen compounds. Proof that Pluto's interior engine was still running. There is a detail about that encounter that rarely makes the highlight reel. New Horizons was flying at nearly 50,000 kilometers per hour. It did not carry enough fuel to break into orbit. The visit was a sprint of hours. High-resolution imaging covered only one face. The far side stayed in darkness. Secrets remain on the hemisphere we barely saw. To understand why Webb and New Horizons keep stunning researchers, rewind to how Pluto entered human awareness. In 1930, a 24-year-old astronomer named Clyde Tombaugh spent nights in Arizona comparing photographic plates, hunting a speck of light that shifted against the stars. Patients found the ninth planet of the era. Later telescopes shrank the myth. Pluto was smaller than Earth's moon. In 2006, the International Astronomical Union reclassified it as a dwarf planet. Overnight, public culture turned a frontier world into a joke, worthless ice ball. NASA did not abandon it. The same year as the demotion, New Horizons launched. Inside that small probe, engineers sealed a capsule of aluminum carrying some of Clyde Toomball's ashes. The man who discovered Pluto became, in a literal sense, the first human remains to reach that frontier. Years of flight to prove a forgotten world still held unbelievable secrets. Those secrets now include chemistry as intimate as origin stories. While Pluto's atmosphere slowly collapses toward the ground, space radiation strikes methane and nitrogen molecules still aloft. Bonds break, fragments recombine into complex organics called tholins, dark reddish dust in the haze. When that material snows out, it stains white ice into dark patches. Prebiotic chemistry lab is running in the cold. The same basic reactions that helped build early organic molecules on primitive Earth are happening now at the edge of the solar system. Proof that life's ingredients can assemble in the most unlikely freezers, cryovolcanoes, and a restless surface raise the next question. Where does the heat come from? For a slurry of water and ammonia to exist inside Pluto, something must warm the deep ice. The rocky core holds radioactive elements that release heat slowly, enough to melt the base of a thick ice shell and sustain a vast subsurface ocean under kilometers of crust. Mass and rotation measurements suggest that ocean may wrap much of the dwarf planet's interior. An enormous reservoir of hidden water widen the map, and the implication grows. Pluto is not a lonely freak. It sails the Kuiper Belt, ring of thousands of frozen bodies beyond Neptune. Worlds like Eris, Makemake, and Quaoar share that dark region. The great turn in astronomy was realizing Pluto is not the weird exception. It was simply the first of those distant worlds we could study in detail. If it hides internal oceans, ice volcanoes, and an atmosphere that refrigerates itself, those neighbors may hide surprises of their own. James Webb made one thing unmistakable: the outer solar system is not finished teaching us. If a dwarf planet once mocked and undervalued can challenge climate physics this hard, what else waits among the thousands of worlds humanity has barely begun to explore? Thank you for watching.